A security researcher found a way to take over entire Google Cloud orgs. Every project, every resource, every secret, with a few lines of YAML and a single command. When he reported it, Google said, "Nice catch," and then 11 days later decided it wasn't a bug. No payout, no CVE, it's still unpatched. But that's not the part that should make you angry. The part that should make you angry is why they say it's not a bug, and the harsh reality of some of these bug bounty programs. Now, if you're new here, my name is Blaze, I hack into systems for a living, and on this channel, I like to break down exactly how that works without the hype. And if you like these kind of exploits, please do me a favor and get hired on the like button's help desk, and then reset the cloud administrator's password and swap every base image in their container registry to Cowsay. Now, the bug itself isn't some exotic, never before seen thing. It's a class of bugs called a confused deputy. It's one of the oldest tricks in the Cloud Privask book. Tenable, the folks from Nessus, they found the same pattern in Google's cloud twice last year, so a little bit of a pattern's emerging. But to get why Google's response is so wild, you first have to understand how stupidly simple this actually was if you understand some Kubernetes kung fu, which I'll do my best to explain. Real quick, you need a few pieces of background for this to make sense. First, Kubernetes is a system that tons of companies use to run their software, but the key is in how you tell it what to do. You don't go clicking through menus, you write little YAML files describing what you want, hand it over, and Kubernetes goes and brings it to life. So it's very declarative. It's your little cloud genie that will grant wishes and misinterpret them if you're not clear. And just like in Docker, where the basic unit of work is a container, in Kubernetes, it's a pod. A pod is a collection of one or more containers, and it just keeps them all bundled together. Second, inside Kubernetes, different teams get walled off into their own little zones called namespaces. You can think of namespaces as your own room in a building. You're only supposed to touch what's in your room. So like each of these container runtimes might be their own namespace. The kube proxy might be in its own namespace. Everything is to get separated. It's a very flexible partition. Accounts can have access to multiple namespaces in there, but somebody with access to just one namespace should relatively theoretically be boxed in. Third, and this is the twist, normally that YAML describes a pod of your own software. It's like an app or a database. Config connectors' whole job, which is the vulnerable component we're going to talk about, is to let those same files describe Google's cloud itself. Create a storage bucket, grant this role. You write the file, tool reads it, and it goes and makes it real on the Google Cloud side. So it's a bridge between Kubernetes and the cloud system. Here's the catch. To do that, the tool has to run as a service account with near godlike privileges. And it kind of has to, right? It's creating and deleting cloud resources on your behalf, so it needs to actually have the permissions to do that. So when you hand it a file, it carries out whatever that file is with its own God tier permissions. And it never once checks whether you're actually allowed to ask for it. That's the confused deputy. It's a powerful helper that does whatever it's told without properly checking who's doing the telling. Now here's the actual flaw, and it comes down to two permission systems that never talk to each other. Inside Kubernetes, we've got RBAC, or role-based access control, and that decides what objects you're allowed to create in a namespace, and basically your room in the building, right? Google uses a completely different system called IAM, or Identity and Access Management, and that decides what you're allowed to do over in the Google Cloud side. And right here in the middle, we've got Config Connector. And Config Connector can take information from Kubernetes and then check it, and then go through and apply it over to the Google Cloud side. Are you allowed to touch this? I don't know, I never even checked. Boom. That's the difference here, is that there's one set of permissions in Kubernetes, there's one set of permissions in Google Cloud, and never between the twixt shall meet. That's the whole bug. You can simply point a file at a resource that you have zero cloud permissions over, the entire organization, for example, or somebody else's service account, and Config Connector carries it out anyway because nobody's checking your cloud permissions. And to prove this is a real authorization hole and not just you gave it too much power, you don't even need to ask for owner. You could ask for read-only on a project that you don't even own, and it would still apply. That's the scary part. Isn't the role that you pick, it's that it's applied at all. And even in the AWS documentation, they've got this listed, the confused deputy problem, down here with a handy dandy diagram that shows everything that's going on right here. Now for you CWE nerds, this is officially classified as a 441, unintended proxy or intermediary. But everybody just calls it the confused deputy. And there's one detail in the blog post that tells you this was probably an oversight and probably not an intentional design choice. Config Connector manages something like 530 different custom resources. That's what these CRDs are. And it does it through roughly 100 different controllers. And only one of those does the authorization check that would have caught this, which means if you can write a file, you could become the cloud god. So let me show you the file. Here's another little diagram I've broken out for you here. So we got the object. It's an IAM policy members. That's a request to grant IAM permission. So we're telling the Kubernetes side through config connector to go apply something on the Google Cloud side. And then we just define who gets it. This is just a random email address I threw in here. Don't pay any attention to it. And then we tell it what permissions they're going to get. Roles owner is the top of the food chain. It's the creme de la creme of all permissions in Google Cloud. And then we tell it which organization you're going to get. So we tell it what the kind is, and it has an external identifier, so you just reference whatever organization you're going to have. Take this YAML file, you run one kube control apply command, and config connector goes, sure thing, fam, and makes sure that some random Gmail account now has the owner of the entire organization. Anyone with kube control access to a single namespace can pull this off. So a junior dev, contractor, somebody who fished a low-level account, and it gets worse in two directions. First is persistence. That owner grant sticks even after you lose your Kubernetes access. You're up in the cloud now, you have ascended. The door you came through doesn't matter anymore. They could tear down the entire cluster and you still be the owner of the org. It's a permanent backdoor. Second, and this is the funny part, you don't even have to be that loud. Instead of crowning yourself owner, you can just do the exact same trick and grant yourself rights to impersonate an account that already has the power. Say a service account for the storage team. Same one-line file with a couple of tweaks and config connector just yeets it out to the cloud. Now you can act as that account. You can go ahead and start deleting production databases or buckets or whatever. And here's the kicker, the part that turns a break-in into a perfect crime. When the incident response team goes and pulls the audit logs to find out who done it, the logs don't say you. They would say the storage service account. There's no trace of a low-level Kubernetes identity that actually pulled the trigger. Config connector has laundered your request into a trusted one. Forensics burns the whole incident chasing the wrong account while the real attacker has already walked out the door. Put it all together, you've got a total takeover, a permanent backdoor, and an audit trail that frames somebody else. And O'Leary scored it a perfect 10 on the CVSS. That's pretty critical, that's as critical as it gets. But to be precise, that was his score. There's no official rating because Google refused to issue a CVE at all. However, let's look at what it takes. To get a perfect 10, it needs to be network accessible, be low complexity, require no privileges, and then have no user interaction. Also, the scope needs to change, meaning you're changing what you're affecting in the system, and it has to have a high impact on the good old CIA triad. And so once we do those, we get a perfect 10. However, there's a minor flaw in this logic here. It doesn't require no privileges, it requires low privileges. It really should have been a 9.9. So what did Google make of all this? Well, let's take a look at the timeline. On March 8th, it was reported to Google's VRP, it was assigned a case number, and then on March 27th, they replied. They literally said, nice catch. They accepted it as a primary one, severity one. Top priority, top severity, queued for a fix. But then somewhere around April 7th to 10th, the timeline gets a little bit muddy. This is how O'Leary reported it. They reversed course and said, that's working as intended, we're not gonna fix it. Then on May 1st, Alphabet actually comes in and says, hey, no, we're gonna refuse you a CVE. They're their own CVE authority, so they get to decide what gets cut as CVE and what doesn't. O'Leary reached out to CERT, and it was marked basically inactive. They're an outside coordinator, but they couldn't even force a number to be issued for it. So then June 12th, O'Leary says, all right, fine. Comes in, drops the demo, drops the disclosure. So from days to report, 96 days, but 0 days of patch development. Now, I actually tried to go log into the VRP system and see if I could read this ticket, but for good measure, it's access denied. I don't really have a ton of experience with Google's VRP. That's their vulnerability research program, by the way. And I just couldn't access it. I tried to get there and corroborate it. So a lot of this, what we're going off is what was on O'Leary's blog. Now sit with the contradiction for a second because it's wild. The bug is simultaneously working as intended and it's an open top severity ticket that's being tracked for a fix. Both those things can't be true at the same time. And here's the timing that made me say, hold up, wait a minute. On March 20th, on Google's own Bug Hunters repo, they had a commit here, and it was a pretty chunky commit. They did a complete reorganization from a text file to some other weird ASCII format. But in here, we see config connector now shows up. From all my Git spelunking, I couldn't find any references to config connector. There was config controller, but not config connector prior to this. And it shows up as the lowest asset tier, which is their classification for IT3. That was about 12 days after O'Leary's disclosure, so make it that what you will. And this isn't some niche tool that nobody uses. Over 10,000 Google's Kubernetes clusters are running config connector. O'Leary estimates that somewhere between 1,000 to 2,000 of them are sitting right there now with that org level blast radius in that unpatched state because Google says, hey, there's nothing to patch. And for the scale here of what Google does pay, if you have a top severity vulnerability listed here, it payouts cap out at like 100K, right? And it wasn't listed in here before. So if we come look at this and we say, okay, it's listed as an IT3, that's this third column. It's not a Sev 0. A Sev 0 is vulnerabilities that exist without any interaction, basically completely unauthenticated. This would be classified as an S1, vulnerabilities where the attacker had prior access to some kind of Google Cloud asset. If I'm reading this correctly, O'Leary should have been paid about $10,000 for this, for a complete org takeover. Instead, he got stiffed. And if you saw my World Cup video, this is the same kind of flip of the coin. Serious bug, payout totally optional. Though FIFA doesn't even have a formal bug bounty program, that's a completely different fail on their part. Now, in fairness, there is an argument on Google's side. Here's the strongest version of Google's case. Google's position is this: the attack only works if you gave config connector very high org-wide permissions in the first place, and handing any tool that much power is, in their words, against good practices. So by that logic, the tool is just doing its job, and the real problem is in how you configured it. And honestly, lots of folks will probably agree, a tool built to execute whatever it's given is going to execute whatever it's given. Go figure. But there's a turn in the punch bowl. That whole "you gave it too much power" defense only works if you went off script. What if you didn't? Google's own config connector documentation walks you through getting the service account, roles, and owner permissions. If we come over here and we just click, there's a handy dandy drop down. Organization owner permissions. And we say to expand the config connector permissions so it manages all projects and folders for a given organization, complete the following steps. And right there is the roles owner permission, the God tier permission. So those excessive permissions aren't a customer screw up, they're Google's documented happy path. And the whole working as intended half falls apart too, because this isn't even a novel bug class. Tenable, the Nessus guys, documented this exact same confused deputy in Google's cloud twice. Once as a cloud runner, they called image runner, and once as cloud composer, which they called confused composer, hence the name config confusion, because there's a lot of confused deputy happening here. And Google patched both of those by adding the very authorization checks that are missing here. You don't ship the same fix twice if it's generally just how it's meant to be. The fix already exists, they've written it before, just for some reason not this one? So O'Leary's actual point was never the tool's too powerful, it's that the tool never checks who's asking. That's the bug, and Google has patched that exact same gap in other places. But here's the part I actually care about, because this was never really about one bug, it's about a missing number. A bug with no CVE basically doesn't exist to defenders. And when it's their own product, the vendor's the one who hands out the number. Refuse it, and the whole thing just quietly slips off the radar. O'Leary hit the identical wall with Microsoft weeks earlier. Same class of bug in Azure's backup systems for Kubernetes, reported it, was rejected, no CVE, and then silently patched anyway. Deny the bug, deny the number, fix it in the dark. That's the new save face playbook for a lot of these guys. So O'Leary made a pretty slick move. He went and became an independent CVE numbering authority himself through a system called GCVE, or Global CVE, and it's run out of Luxembourg. One of the only handful of solo researchers cleared to do it, which means when a vendor refuses a number for a cloud bug, a trusted outsider can now just hand one out anyway. The quiet fix game plan is dunzos. So here's what I want you to do. If you run Google Cloud, go check whether you've got config connector deployed and what it's actually permitted to do. Go check those permissions on it. Maybe you want to dial those back just a tiny bit, maybe rein it in a little bit. But that's all I got for you today, guys. I want you to go check your cloud, and remember, I love you. Peace.